Welcome to Beyond the Bit Quantum Pathways, the podcast where we explore the exciting world of quantum careers. I'm Amir Rasool, your host, here to bring you inspiring stories from industry pioneers, researchers and innovators who are shaping the future. Whether you're a career changer, a curious mind or an aspiring quantum professional, this is your gateway to discovering opportunities in this groundbreaking field. Welcome to our podcast on quantum computing. Today, we're thrilled to have with us Matthias Kaiser, who's a true quantum pioneer making waves in this field. Matthias brings a unique blend of theoretical knowledge and practical business acumen to the quantum computing landscape. With a master's degree in physics, specializing in theoretical quantum information theory from the University of Vienna, Matthias spent the last 13 years navigating the tech and deep tech industries. Currently serving as an account executive at Kipu Quantum, he's on a mission to make quantum computing useful by bridging the gap between quantum algorithmic expertise and real-world business applications. Matthias is not just a practitioner, but also a thought leader in the quantum space. He's a sought-after keynote speaker at industry events, contributes to newsletters, and actively participates in the QuIC MTU working group, where he helps analyze and rank quantum computing use cases. With his extensive experience in business development, sales, and product strategy across various tech companies, Matthias brings a pragmatic approach to the often complex world of quantum technologies. Today, he'll share his insights on the current state of quantum computing and its potential to revolutionize industries. So let's dive in with Matthias Kaiser. Hi, Matthias. Welcome to the podcast. Thanks for joining me.
Hi, Amir. Yeah, thanks for having me. It's a real pleasure to be here and talk with you today.
Yeah, no, it's great to catch up with you again. It's been a while since we spoke, especially about quantum. So I think it'd be really interesting for our listeners to get your perspective for the reasons which I mentioned in the introduction and your experience in the tech industry for 13 years. So as I said, this podcast is about educating people about the relatively unknown field of quantum computing. And I need people like you to help show how people can get careers in this space or what's happening, etc. So educate and inform, I suppose, are the words. So we'll kind of kick off. Obviously, you've got a background in physics with a focus on theoretical quantum information theory. I suppose what inspired you to transition from academia to the business side of quantum computing?
So actually, the transition was not direct. So after doing my master in Vienna in theoretical quantum information theory, I actually decided not to stay in the university. First of all, it was theoretical, very heavy theoretical topic. So I wanted to do something real and decided not to do a PhD at the time. And didn't want to stay at the university without doing my PhD. So I thought it's a good idea to move into the industry and do something. And actually at the time, there was no quantum industry to talk about. It's like 15 years or something.
Interesting point. Yeah.
So I actually started out in different other industries. So I moved actually to Latvia at the time because my then girlfriend, now wife, is
mother, I believe, of your child as well.
Yeah. So I stayed actually the last 13 years in Latvia. Was working there in different industries, had my own startup, which I was leading as a CEO in field of industrial AI and machine learning, and then had the opportunity to come back to Germany and join a company that was active in the field of quantum computing. That was recently last year purchased by Kipu Quantum. That's how I ended up at Kipu Quantum.
Of course, yeah. So we'll come on to that as well. So like you said, you've been in the industry for 15 years now. How did you first become involved in quantum computing, I suppose, and what drew you to this field?
Yeah, that was actually quite interesting. So I was studying for my bachelor's here in Frankfurt. I'm from Frankfurt in Germany, and I was studying for my bachelor's degree. And we got one course in quantum information, like from a guy who came recently back from Canada, working for a bank, and he did very nice course, but there was nothing else. I was very interested in the topic, but there was nothing else going on in Frankfurt. And then I started to read the books of Anton Zeilinger, who received also Nobel Prize, I think 2 years ago it is now.
Okay.
And found it very interesting and just wrote them an email basically and said like, hey, can I come over to Vienna with the summer holidays and do an internship with you? He said yes. So I went for 6 weeks to Vienna and did an internship with Anton Zeilinger, and then decided when I was there that actually after my bachelor, I want to go to Vienna to study quantum information theory. And this is what I did in my degree in a more theoretical field, but I had also the luck of interacting there with most of the guys in the theoretical, but also in the experimental side of quantum information. So it was very, very interesting, journey.
Sure. I mean, amazing that you just basically took the initiative to send an email and say, "Hey, look, can I get involved?"
Especially I mean, I was also not expecting that he would write back, to be very honest. Yeah. But
sometimes I bet you wish he didn't. God, it's such a hard field. Okay, like you mentioned Kipu there. We'll come on to that in a second. So, obviously, Kipu is not your first business role, as I'll call it, within quantum computing. You were at a company that was acquired by Kipu. What were they doing, and what brought around the acquisition?
So basically, I was working before for a company called Anacor. They were involved in a project financed by the German Ministry of Economics to build. Basically, the project was to test different applications of quantum computers in the industry. So basically, search for use cases within the industry and then test them on real or simulated quantum hardware. Anacor was leading this consortium and was also developing a platform that allowed to basically offer different kind of algorithms on an API basis, also connected with hardware. So you basically can consume quantum resources using API calls, which is very, very good if you're an industry company that maybe is not that familiar with quantum computing and wants to have it like in a manner that they understand it. An API by now, software as a service, most companies are understanding well. And that platform was actually mid of last year purchased by Kipu Quantum with some of the key employees where I was
such as yourself, obviously.
Even me basically.
So you're currently account executive at Kipu Quantum and focusing on making quantum computing useful. Can you share examples of real-world applications where quantum computing has shown promise for Kipu or just generally?
I mean, this is a very, very hard question because that's
why I asked it.
That's like kind of the holy grail of quantum computing. Probably, if I would know it, I should not tell it here, but build a business around it.
We won't release the podcast, and we'll just we'll go elsewhere ourselves.
Exactly. No, I mean I think it's very, very difficult to find good applications because I mean when you look like there are different layers. It's like peeling the onion, right? It's like you have on the outside you have like of course everybody's talking about the three big topics is basically simulation, so simulating quantum systems with quantum computers, it's optimization, and it's quantum machine learning. These are, I think, the three main topics everybody's talking about. But then when you go more and more detail and talk with actual customers, it gets like more sophisticated, like smaller details come out that can alter this quite a lot, right? It's always a question. You have an application, you have to find the right tool to do it. You have to find the right way of doing it. So that means you have to generate a mathematical implementation of the problem you want to solve. Then that mathematical implementation has to fit on the hardware. You have to choose the right hardware, so the right algorithm, the right hardware, and that all has to fit together. But then you have also business needs, right? That all has to fit. This technical implementation has to fit then also with business impact, with regulation. That is also a big thing, right? You don't want to start as a startup in a field that is highly regulated because it's always a bad idea because that costs money, time that you don't have to get certification and stuff like that. So you basically always search some kind of sweet spot of something that is technologically possible. Also maybe in the near term, you don't want to wait probably another 30 years until you can implement it. You want to find something that has reasonable business impact on the customer you talk with. And then you have to also find something that is low on regulation and certification. That is, as I said, that's the holy grail, right? We're all searching for that.
Well, it's a loaded question, but it's always good to get people's opinion on that. Obviously, we're in the year of quantum, 2025, and the last 12 months have seen significant growth from my perspective. Obviously, I'm a recruiter. I'm looking at companies who are starting to look at the technology. Obviously, it's not there, but it's a case of when, not if. So it's always interesting to get that. And obviously, this part of this podcast is to give people realistic expectations of the field, because everybody saw the AI bubble and so on and so forth. And they're like, oh, quantum is like, yeah, okay, it is interesting, but let's be realistic about it. Which brings me on to QuIC. Obviously, you're a member of the QuIC MTU group, which basically looks at analyzing and ranking quantum use cases, I believe. I suppose, how do you evaluate the potential of different quantum applications, etc.? How does that work? How does the group work?
So basically, what we're doing there is we look at different kind of use cases, potential use cases. I mean, there's a long list. You can find online tons of that. Every participant of the QuIC consortium, which is a large industry consortium, right? There's a lot of companies who have potential use cases for quantum computers as well. We're all putting together use cases, and then it's a matter of scoring, right? I already said before, there is technological feasibility is a big thing. Like, it's not just if it's feasible, but also when it's feasible.
Interesting. Yeah.
Because it's probably a harder discussion with the management of a company if your application that you're pursuing is away 30, 40, 50 years. And another discussion if it's away maybe months or 2 years or something like that, right? So this has to be taken into account. Then there's business impact is, of course, important. If you solve a problem that has zero business impact, then you don't also need to solve it, right? These are most of the currently quantum supremacy claims that were made on stuff that is absolutely useless. I mean, it's nice from a scientific, academic perspective. It's of course interesting, but there is no value further than having shown it in it. And this is, I think, a general issue that often for the industry we're working in, it's very hard to see that. I mean, like, I'm a physicist. I understand that I have worked a lot with people from academia, but also people from business, not just in quantum computing, also before. I know the difficulty, right? Like, things that sound for somebody coming from academia, it sounds absolutely crazy that, for example, you talk with a company and you present them as a solution that might solve all of their problems. And they start to say like, oh, but we can't really implement that. Yeah. It's not understandable for somebody from academia. But then if you look from a business perspective, it might be a reasonable way to go, right? Like, even if you can improve their application by 50% or even more.
It's like a 1 degree shift in X amount of years or miles makes a huge difference. So it's an interesting point, that, because you've worked in various roles from CEO to business development manager. So you've got a fair amount of the business acumen outside of quantum. How important do you think that is for people who are looking to make an impact in the quantum industry?
It's absolutely needed. I mean, it doesn't work with either only a business side or only academic side. I think you need both. And this is kind of like a very, very small group of people currently in the world that has that ability to move between business and academia. Because if you only see the academic side, as I said before, you look at it more from a technological perspective. Sure. But many, many constraints within companies are not technological constraints. If you want to convince somebody, you convince, first of all, an organization, but you also have to convince people. You want to, I started already, I told you before about, right? You come in a company, you want to introduce the best thing ever to them. That might not work immediately because you have to convince people to exchange probably a solution that is running the past 10 years that everybody knows, that is maybe not great, but it's doing its job. And you ask from them, basically, take this thing which you don't know, it's much better, but replace it with that. Yeah. And that's a hard sell because it's not just, because there's a person who sits there who has to make the decision.
And they've got to sign off the decision. And the decision's got to make money, not lose money. And it's on a speculation aspect.
Yeah, I mean, if it works, it's good. Everybody is happy. But if it doesn't work, it's his job, right? And there's many people who will not risk that. And that's one thing you have to understand when you want to sell to companies. That often it's not just a technological discussion. There's a lot of like constraints that live around that. I already talked about regulation, certification problems, but there's also a lot of people and politics involved in doing that. So both is necessary.
Yeah, so obviously you're in a quantum company, you've got a quantum theoretical background. What do you see? I mean, we kind of touched upon this, but what do you see the biggest challenges facing the quantum computing industry are today? I suppose to summarize it.
I mean, I think I talked already about use cases. And use cases only can come in cooperation with the industry, right? Yeah. You need on the one hand side the solution, but you also need the problem. Yeah. And this is, I think, of course, we can talk now about technological things like improving fidelity of qubits, lowering gate times, increasing coherence times of qubits, stuff like this. Of course, this is all necessary. Yeah. But even that is, I think, the biggest mistake we're often making in the quantum industry. Even if there would be tomorrow quantum advantage, that doesn't mean that we will sell quantum advantage code to industry players. Sure. There's a lot more to it, which has to a lot more work that has to be done to actually sell a solution. And I think this is the biggest holdback, to basically find proper solutions and then find proper applications and then build solutions for them. Because this will be the only thing that business people will be interested in. Sure. They don't want quantum, they want that their problems are solved. That is what they want.
And you've been kind of looking at that, because I also know that you write a newsletter called Entangled Threads, which kind of analyzes different aspects of quantum, where we are, what's the latest news, what does that mean, etc. So can you tell me a little bit about Entangled Threads?
Yeah, I mean, it's actually was born like last year out of basically I'm doing that anyways on a daily basis, looking to markets.
So educating yourself.
Educating myself. And I felt like sometimes educating yourself just for the reason of educating yourself is not very motivating. So one reason. So one reason of going into doing the newsletter was a very selfish one, was basically to motivate myself to do more research and share it with others. Then on the other side, it's of course great when sharing with others. You also learn more. That I learned in university. That is a great tool. But of course, also, I want to write about interesting things. I saw that there was a need to write in an easy way. So I tried to understand.
Just exactly what I was about to say. What I love about your newsletter is this. I mean, I'm similar to you. From a recruitment perspective, I try and stay on top of technology to understand what's around the corner, what pain points people will have. So then, as a good recruiter, I can preempt that and try and find people. And this is and I'm not a scientist. My background's law, although I've been a tech recruiter for a very long time. And what I love about Entangled Threads is it dilutes it down to a level that I can understand and absorb, and it just makes sense. Because like you're talking about qubits and we're talking about error correction. Some people talk a very high level, which is great, but you need to have a very high level understanding to be able to fit all of that together. And sometimes you don't have the time. You know, okay, I need to analyze this. I need to figure what it means. And this is why I like Entangled Threads.
I really try hard to basically distill out like the easy to understand parts of it, right? It's often a lot of work, I have to say, to do that, because to basically make it easy, I have to understand it quite well. The topics,
this is it, isn't it? Fun. Yeah. Well, this is it. People see like and it's a 3-minute read. That can take a few days to analyze, understand, etc. But you know what? You're doing a great job. And when this episode goes out, I'll put a link to it. But while we're on the subject, how can people find Entangled Threads?
You find it on LinkedIn. It's a LinkedIn newsletter. You can check out the link that is connected to that podcast, or you can also find it over my LinkedIn account. You can just search me by Matthias Kaiser. You will find me there. Here is my name, so you will definitely find me. Connect to me if you want to, or just subscribe to the newsletter.
Excellent. So I suppose, given your experience in sort of technical and business aspects that we've been talking about in quantum computing, What advice would you give to somebody who's looking to bridge that gap between quantum theory and maybe practical applications?
I mean, as I said already before, it is necessary to understand also the business side of everything. So I can just suggest to not see the world too much out of an academic perspective. It is important, of course. It's a very, very technical field. So you have to understand the technology. So some academic background is definitely necessary. But for the people coming from academia, it's definitely a good step also to look into the industry, to maybe find a job, not first in a university-run startup or something like this.
Interesting.
Maybe look first in an industry field to get some perspective what is needed, because you will be humbled by the experience when you come. I had that with my own startup. You think you have to have the best thing, right? The best technological thing, and you come to somebody's shows and say like, here you can improve your processes, everything will be good, and they say like, but you know, so it's a very humbling
there as well. Funny you say humbled, because there's something that you mentioned which stuck in my mind. You basically said it's slightly off topic, so we've kind of pivoted a little bit, but the most outrageous technological visions will be humbled by time. It's a statement that you made, which just stuck in my brain. I'm like, that's a cool sentence in its own right. But yeah.
So this is basically, I mean, the idea behind it is based on the law of accelerating returns by Raymond Kurzweil, which is then based also Moore's law, on which we all know. It's basically that in the near term, we overestimate the technological progress, but in the long term, we greatly underestimate it.
Interesting.
Right? This is a statement often made, and this I wanted to express with that, because I think when we talk now about use cases for quantum computing and stuff like this, we all think we know everything about quantum computing. Mm-hmm. The truth is that probably the use cases that will actually work and will actually generate huge success for quantum computing will be completely different. Nobody will have even thought about them now.
Exactly. Yeah.
And we can all pretend that we know what the future brings, but I don't think so. I saw it I was with my own company. We were active, for example, in additive manufacturing.
Yeah.
Additive manufacturing, they started with like just putting the same files that they would mill into a 3D printer, and were wondering why they got worse parts that were much more expensive and didn't look very good out of that, until they understood actually that using a 3D printer, you have to make different parts. There are different properties or different properties that a 3D printer has that you can actually use, that are good, that bring benefits, and so, some downsides you don't want to have in your parts. Same thing will be for quantum computers.
Yeah.
Probably we're still all thinking way too classical to do anything.
Well, we are, aren't we? We're looking at the same things. We're looking at the cryptography, we look at the machine learning, and you know, I think when we're progressing towards it, and at some point we're going to get to a point it's going to solve a problem that we didn't even know we had, which is fascinating.
Exactly. I mean, what like when you look at the stuff that happens before the internet was coming out, what people thought what you could do with a computer, absolutely outrageously stupid ideas. When we think about,
I had the 32K Acorn Electron when my first computer, and then I upgraded to a 48K Spectrum, and you think about the computing power that is just surrounds us now. It's just crazy, you know.
I mean, every watch. I mean, every watch has more computing power than the old PCs, and it has brought a lot of applications we would not even have thought about.
Yeah,
like who would have thought about a podcast 30 years ago that somebody would download some audio file on a device? Absolutely crazy idea with the internet,
and hear us rambling about quantum computing. Exactly.
Yes, exactly.
Fantastic. I suppose that's to wrap up, I suppose, and and revert back to the students and the newbies who are coming into this film. For students and professionals considering a pivot into quantum computing, What resources or experiences would you recommend they seek out? I know you kind of mentioned it, but I'll just kind of summarize that for those going forward. So people who might have,
I mean, resources, there are plenty. It depends on what you want to do. Depends also what you want to do, right? If you would like to be a quantum programmer, probably the IBM QuIC and the IBM Quantum Learning platform is an amazing place to start. There's also a lot of information on the Planck platform of Kipu that you can use. You can also make a free account and play a little bit around. So if you want to do programming and you want to work really hands-on with quantum computers, a Planck platform and the IBM Quantum Learning platform are definitely two places you should check out. Then, of course, the many newsletters that are out there. It's
specifically
not just
Entangled Threads, right?
Definitely that one. But
yeah, no, I agree. Yeah. And QuIC, just to throw QuIC in there, that's the European sort of quantum community, isn't it? So I think you have QEDC in the States.
Consortium. Yes.
Yeah. So, and I think that, I mean, I've looked at them and they have got a few resources there as well. Quite interesting.
They have quite a few resources as well. Definitely, there's also some good courses on university by now. That was in my time. There was not much practical stuff. So now there is also if you're coming from IT direction, there are courses for quantum computing, and that are, I think, quite good. And there are many, many more opportunities. If you want to do it more from a business perspective, I really would suggest to look more into applications of quantum computing than into necessarily programming.
Sure.
For me, I know tiny little bit QuIC, but I'm not I'm not a great coder, but it's also not necessary for me. For me, it's more the understanding of use cases, the needs of customers. And I think that is a great place to start, actually, also to understand what actually people need and want, because this will be the next generation of quantum startups.
100%. And since I've been focusing on this, which is coming up to 2 years now, one thing I've noticed is you have the great brains who are building the QC ecosystem, but you've got to get that message out there. People need to be able to understand what it does, how it does it, what it can do for you, then bring that information back, tell the company, and that's how this will all move forward. So huge. I mean, you call it sales, education, pre-sales. This is going to be that's going to be needed. So people who can cross both fields, there's going to be huge demand for them, because, a lot of technical people don't want to necessarily get into the business world. The business people don't want to get into the technical world. So if you've got the ability to straddle both of those worlds, that's a very interesting and growth area. I mean, and it's already growing. I mean, so very interesting. Yeah.
Yeah. I mean, if a company wants to move into quantum, the first thing they need is not somebody who can develop quantum code, but the first thing they actually need is somebody who can explain the management and the rest of the team what quantum computing is, how they can use it, identify use cases within the company. And I think this is the first step. Of course, outside companies can help, but at some point, every company, every industrial player in the world will require somebody like that to do the translation between the two fields.
Exactly. Well, I think that's a great point to kind of finish off our conversation. Matthias, it's been once again absolutely lovely to catch up with you. Thanks for all of your words of wisdom here, and thanks for your time. Very generous of you. As with all our guests, my plan is to come back and catch up with you again in a few months' time, because I think it's important to show your progression, Kipu's progression, QuIC's progression, and for the listeners to grow with, to go along with that journey, because it'll educate them more. As your role changes, as Kipu's role changes, we can give real-time information to people who might necessarily get the opportunity. So we will catch up again in a few months' time for a new podcast, if that's okay by you.
Yeah, I would love to do that.
Wonderful.
It was really a pleasure to be on your podcast, Amir, and I'm really looking forward to the next time as well.
Thank you very much. Take care. Bye-bye. And that's a wrap on today's quantum adventure. We hope you enjoyed the show. Please subscribe, share it with a fellow quantum enthusiast, and leave us a review. It helps us reach much more curious minds. If you have any questions or feedback, please reach out at beyondthebit.quantum@gmail.com. Stay tuned for more exciting explorations into the world of quantum.